Okay, 6.3 was pretty difficult in my opinion. Not necessarily that, well, I should rephrase that. It wasn't necessarily difficult, but it was a necessary thing to be able to complete the rest of chapter 6. So if you didn't understand 6.3, that's why I kind of slowed way down on that one. Then it was going to be hard to do 6.4, 6.5, and 6.6. Now, with that being said, these sections are a lot shorter, and really 6.5 is some of the exact same things we covered in 6.3. It's going to be pretty easy to talk about, and so is 6.6, which is solving them. So I'm going to cover 6.4, 6.5, and 6.6 today. 6.4 will be the longest section that is on here. And 6.4 takes care of adding and subtracting and multiplying radicals. And we talked about how the word radical is just a fancy word for square root. Okay, so how do we talked in 6.3, we talked a whole lot about how do you reduce these. In 6.4 and 6.5 and 6.6, now that we know how to reduce them, what can we do with that from there? So what it basically does for us is it makes it a whole lot easier to add, subtract, multiply, and divide them once we're able to reduce them and understand how you do that. And so I will be talking about how to reduce them while I'm doing this, but if you're not understanding what I'm saying, it would be a great idea to go back and watch 6.3 because I really slow it down there. So our first example is to take 4 times the square root of 6 plus 7 times the square root of 6. And what I want you to notice on this one is very easy. And the reason that it is easy is because both of these say square root of 6. It would be similar to if we had 4x plus 7x. Those are like terms. We can add them. So 4 square root of 6s plus 7 more square root of 6s. You're just going to take and add the 4 and the 7. And then that's going to be how many square root of 6s you have. So it's going to turn out to be 11 square root of 6. So same thing here. I've got 2 square root of 3 plus 8 square root of 3. So since they're both square root of 3s, I'm going to say, okay, well, that's 2 plus 8 times the square root of 3, or 10 square root of 3. Okay. Now, one thing that I would want to do if I'm working this problem, especially on a test, I would want to make sure they were reduced. In other words, if you break 6 down into the prime factors of 6, it's just 2 times 3. There would be no pairs that we could pull out like we talked about in chapter 6, section 3. And the square root of 3 is the same thing here. It's not going to reduce. There's nothing I can pull out of that, but I would want to check that before I moved on. Okay. So what happens whenever we're trying to add or subtract them and they're not the same? Like this one has the square root of 8 and the square root of 32. Well, I can't put those together because they're not the same. But what I can do is see if they will reduce, and if they will reduce, maybe they'll reduce to where they are the same thing, which is what is going to happen to most of these. So remember that when we reduce them, you're going to break 8 down into the prime factors of 8. So I always start with 2 because 2 is a prime number. If 2 won't go, then I go to the next prime number, which is 3. But 2 does work here. 2 will go into 8 4 times. 2 will go into 4 2 times. And 2 is prime, so I can stop right there. So 3 times the square root of 8, which an 8 is really 2 times 2 times 2. Then I would do the same thing with the 32. I'm just going to bring my minus sign down, but I need to find the prime factors of 32. Well, 2 goes into 32 16 times. I always start with 2 if the number's even, and I keep going with it until I can't anymore. 2 will go into 16 8 times. 2 will go into 8 4 times. 2 will go into 4 2 times, and 2 is prime, so I can stop right there. So the square root of 32 is 2 times 2 listed 5 times. Now, remember that we can pull out front anything that has a pair. So I have a pair of 2's, so that can come out front. This 2 that's left would stay in the back. Okay, I'm going to bring my minus sign down, picking out my pairs of 2's, so I can bring a 2 out for this pair of 2's. I can bring a 2 out for this pair of 2's, but this one right here doesn't have a pair, so it stays underneath the square root. When I simplify that, 3 times 2 would give me 6 square root of 2's minus 2 times 2, which is 4 square root of 2's. 6 square root of 2's minus 4 square root of 2's is going to leave me with 6 minus 4, which is 2 square root of 2. Okay. Got 5 square root of 18 minus the square root of 50. Well, I'm going to have to do the same thing because this is a square root of 18 and this is a square root of 50. They're not going to reduce. They're not going to be able to be subtracted. So if they will reduce, maybe they will reduce to something that is the same. So that's the goal. We want to look at 18. 2 will go into 18 9 times. 2 will not go into 9, so I'm going to go to the next prime number, which is 3. 3 will go into 9 3 times. Okay, and so I know that 5 times the square root of 18. 18 is 2 times 3 times 3. I'm getting those numbers from right here. Then I'm going to bring down my minus, and then I'm going to do the same thing with 50. 2 will go into 50 25 times. 2 will not go into 25. The next prime number would be 3, and it will not go into 25, but 5 will, 5 times. And so 50 is 2 times 5 times 5. Okay. Now we can pull out anything that has a pair of numbers. So I'm noticing I'm just going to bring this 5 down here. And I'm noticing that there is a pair of 3. So that 3 gets to come out of the radical sign. And the 2 that doesn't have a pair has to stay underneath. This 5 that has a pair gets to come out of the radical sign. The 2 that does not have a pair has to stay underneath. So 5 times 3 is 15 square root of 2 minus 5 square root of 2. That's going to get me 15 minus 5 square root of 2, which is 10 times the square root of 2. And that's going to be my final answer. So on these problems, you can expect to see that sometimes they're going to be where they are, the goal is going to be to reduce them. And when you reduce them, a lot of times it's going to work out where they end up being the same thing so that you can put them together. Okay, so we're going to talk about some multiplication on 6.4. And the first example says we're going to take the square root of 5 and we're going to multiply it by the square root of 5 minus the square root of 2. Okay, now one thing you're going to notice is there's a cheat when they are exactly the same when you're multiplying. And we'll kind of discover what that cheat is so we don't have to do so much work. But for right now, we're going to take the square root of 5, we're going to use the distributive property and multiply it by both things on the inside of the parentheses. So the square root of 5 times the square root of 5. I'm just going to write that as the square root of 5 times 5. I multiplied these two together. Okay, and then I'm going to do the square root of 5. Well, so pardon me, I'm going to bring down this minus sign. And I'm going to do the square root of 5 times the square root of 2. Okay, and you can just put them both underneath. Now, what we know about this is that if we have a pair of things, that we get to pull that out. And so I can take out the 5 underneath the square root because that 5 times 5 is 25. The square root of 25 is 5. Okay, so if you're multiplying things that are the same, what's going to happen is just you're going to end up with that number that you're multiplying. If they're different, that's a whole new ballgame. The square root of 5 times 2, that's going to give me 10. You'd want to see if you could reduce 10, but I know that the prime factors of 10 are just 2 and 5, and so there's not going to be a pair I can pull out. So that would be my final answer on that one. Okay, I've got the square root of 6 times the square root of 6 minus the square root of 7. Okay, and remember that we have a trick. If we're doing if we are doing square root of 6 times the square root of 6 and they're the same, then we should just end up with 6. I'm going to go ahead and show the work again just to make sure that you're okay with that. But the square root of 6 times the square root of 6 would take care of this one, minus the square root of 6 times 7. Okay, and so this, since we can pull out a pair and there's nothing left, is just going to be 6. Now, when we look at this, we know that 6 is not prime. 6 is really 2 times 3 if you write the prime factors of it. And the reason that I'm stretching this out is to make sure there's not any other pairs that I can pull out. But there's not, right? There's not, even when I list 6 as a prime number, 7's already prime. There's not going to be anything I can pull out of that. So I'm going to end up multiplying 6 times 7, which is the same thing as 2 times 3 times 7, which would give me 42. And then that would be my final answer on that. Okay. So if I have, now we're gonna make it where we're using FOIL. So we're gonna multiply, make it a little bit more complicated. Okay. So we know that we do, when we're doing this, it has these square roots or these radical signs. But other than that, it's exactly the same as using FOIL. So we would do first, which would be the square root of 3 times 5. Okay, then we would need to do outer, which is the square root of 3 times 2. And this is a positive times a negative, so it was going to be a minus. Then we do inner, which is going to be these two. So in positive times a positive is going to stay positive. 7 times 5. And then we want to do last, and this is a positive times a negative, so negative square root of 7 times 2. Okay. Now, what I'm noticing about every single one of these numbers is that they are all prime. I've got a 3 and a 5 and a 3 and a 2, 7, 5, 7, 2. Those are all prime numbers. So when I multiply them, I don't have to see if they'll reduce because I've already, since they're all prime, I know there's not any pairs I can pull out. This is going to be 15. This is going to be the square root of 6. 7 times 5 is 35. And 7 times 2 is 14. And there's absolutely nothing else I can do with that because those are all different. So they're not going to combine to give me something that is the same. Okay. I'm going to scoot over here. We've got the square root of 2 plus the square root of 3 times 5 minus the square root of 2. So we're going to do first. So the way that you would write the square root of 2 times 5, you usually put the 5 in the front, the square root in the back. So that's going to be my first. We've got outers, got a positive times a negative, so it's going to be negative. And we're doing the square root of 2 times the square root of 2. Inner, well, that's going to be 5 times the square root of 3. And last, a positive times a negative is going to be negative 2 times the square root of 3. Okay, everything that's underneath my radicals, they're all prime numbers. So this is just going to stay 5 square root of 2. This is a pair, so I could pull it out of the radical and just make it a 2. Really can't do anything with the 5 square root of 3 right now. There's no pair I can pull out of this, so that would just be 2 times 3, which is 6. So I would look, if there was another square root of 2, I could add them. Or if there was another square root of 3, I could add it or subtract it. Or if there was another square root of 6, I could add or subtract it. But there's nothing else I can do with this. It's done. There's nothing I can combine because there's no other like terms. Okay. So we've got 2 square root of 3 plus the square root of 5 times the square root of 3 minus 4 square root of 5. So we do first, the 2 stays on the outside. On the inside, I've got 3 times 3. Outer, we've got a positive times a negative, so that's going to be negative. 2 times 4 stays on the outside, and 3 times 5 is going to go on the inside, what's underneath the square root. Inner, they're both positive, so the square root of 5 times 3. And then last, negative 4 times 5, square root of 5 times 5. Okay. I'm going to make sure that everything under my radicals that are listed right now are prime, and they are. So now I want to see, do I have any pairs of anything? And I do have a pair of 3s, so those get to come out of the radical and go with the 2. Minus, I don't have any pairs of anything, so I'm just going to go ahead and put this together. 2 times 4 is 8. That's going to be the square root of 15. No pairs here, so that's just going to be positive square root of 15. And then this 5 can come out with the 4 because there is a pair of 5s. So that's going to be 6 minus 8 square root of 15 plus the square root of 15 minus 4 times 5, which we know that 4 times 5 is 20. Okay. I'm noticing that these 2 square roots are exactly the same, which means I can put them together. There's no number on this one, and it works exactly the same as it works with an X. If there's no number, that means you have one of them. So we can put these 2 together. Negative 8 plus 1 square root of 15 would be negative 7 square root of 15. Negative 8 plus 1 would be negative 7. Then these other numbers would be like terms 2. The 6 minus 20, 6 take away 20 would be negative 14. And it would be perfectly fine to write the negative 14 in the front and the negative 7 square root of 15 in the back. These mean the same thing. As long as the sign stays the same, they're going to be the exact same thing. Okay. Got 4 square root of 6 plus the square root of 2 times the square root of 6 minus 2 square root of 2. So first, I'm going to do 4. Then underneath, we've got 2 6s, so 6 times 6. Outer 2, so a positive times a negative, so it's going to be negative 4 times 2. I multiplied the numbers on the outside. Now I'm going to multiply the numbers on the inside. 6 times 2. Okay, inner, both of those are positive, so this is going to be positive 2 times 6. And then last, okay, I only have one number on the outside. It's negative. And then we've got 2 times 2, which underneath the radical. Now, a couple of things here. 6 is not prime, okay? But it does not have, well, we'll go ahead and list it the way So if we list the prime factors of 6, we know 6 is 2 times 3. I'm just, every time I see a 6, I'm listing 2 times 3 underneath that so that you can see that we have some pairs here. Like on this one, we've got a pair of 2s that can come out with the 4, but we also have a pair of 3s that can come out with a 4, and there's nothing left under the radical when I do that. Minus, now we've got our 4 times 2, but these 2s have a pair, so those could come outside, and then underneath we would have the square root of 3 still left. There's a pair of 2s here, so that those 2s get to have one come out. This 3 would have to stay underneath, and then minus 2 times this pair of 2s gets to pull one of those out. We wouldn't have anything underneath. So 4 times 2 is 8. 8 times 3 is 24. Minus 4 times 2 is 8 times 2 is 16 square root of 3's. Then we've got plus 2 square root of 3's, and then minus 4. So the things that can go together, of course, the whole numbers, 24 minus 4, can go together, and that's just going to give us 20. And then these are both square root of 3 so that they can go together and get negative 16 plus 2, which would be negative 16 plus 2 is negative 14, and then that would be square root of 3. It would also be correct if you wrote that in the front, negative 14 square root of 3 plus 20, because it's a positive 20. These mean the same thing. Okay. So a lot of students, when they see something like this, the common mistake is they try to say that this is equal to 2 squared, which is 4, and then the square root of 6 squared, which is 6, and say it's 10, and they're done. But that's not what this means. Okay, when you square this, you're multiplying it by itself. You're not doing distributive property here. So don't do that. It means 2 plus the square root of 6 times 2 plus the square root of 6, which is not going to get us this. So we would go to the same steps we were using before. First, so 2 times 2, outer, which would, since they're both positive, that would be 2 times the square root of 6. Inner, both positive, 2 times the square root of 6. Last would be the square root of 6 times the square root of 6. Okay, so this is 4. These are already written in square root of 6, so I know I can put those together. But let's wait a minute to do that. And the square root of 6 times the square root, that's a pair, so we can bring that out and make that a 6. These two, the 4 and the 6 can go together and get me 10. And then the square root of 6's, I've got 2 of them and 2 more of them, so I've got 4 square root of 6's, so that would be my answer, which is exactly the same as 4 square root of 6 plus 10. These things are the same. Doesn't matter what order you write those in. Okay. So similarly, when you subtract these, this is not 9 minus 7. Okay, you don't want to just distribute that. You need to actually write out 3 minus the square root of 7 times 3 minus the square root of 7 to make sure that you're getting everything multiplied. Okay, you're squaring it, which means you're multiplying it by itself. So 3 times 3, which is 9. I've been listing out all the steps, so let me go back and do that. So 3 times 3. Then we want to do the last terms. So one of them is negative, so a positive times a negative. So negative 3 square root of 7. The inner terms, going to be a negative times a positive, so negative 3 square root of 7. And then the last terms, one of them's negative and the other's negative, so positive, because a negative times a negative is positive, and then we would have 7 times 7 underneath our square root. Okay, so 9 minus 3 square root of 7 minus 3 square root of 7 plus, there's a pair of those, so that gets to come out. 9 and 7 would go together to get me 16. Negative 3 square root of 7 and negative 3 square root of 7 would be negative 6 square root of 7. You could also put the negative 6 square root of 7 in the front and the 16 in the back. These mean the same thing. Okay, let's look at one more example. What happens when we have the difference of squares? So if I have 5 minus the square root of 2 plus times 5 plus the square root of 2. Still going to do the same process, but because one of them is negative and one of them is positive and they're exactly the same, other than that, the middle terms are going to end up canceling out. Okay, so in it, if you want to, you can go ahead and go and multiply them out. But I'm going to do that just so I can show you. My first terms are 5 times 5. It's inner. Outer is going to be plus 5 times the square root of 2. Inner, I've got a negative times a positive, so negative 5 square root of 2. And then last, a negative times a positive, that's going to be negative square root of 2 times the, sorry about that, times the square root of 2. Well, 5 times 5 is 25. I can take care of that. This right here is going to end up turning into 0, which is because we've got positive 5 square root of 2 and negative 5 square root of 2, which is what I was talking about. That's going to end up canceling out. It's going to happen every single time one of these is positive and one of them is negative, because that's the difference of squares. So we've got a pair of 2's here, so we can pull that out. I'm going to bring the minus sign down. And so we end up with 25 minus 2, which is 23, which is the final answer there. So everything kind of worked out where you just got one number. Okay. We are moving on to 6.5. 6.5 is has 6 problems, 6 examples that we need to look at. And the whole goal of 6.5 is to rationalize the denominator. 6.5, we're going to rationalize the denominator. And if you're like me, it would be like, what in the world does that mean? So hold on just a minute, and I will explain that to you. If we saw a fraction and the fraction that we saw was 8/10, we would know that that fraction is not reduced, okay? Because you could divide the top by 2 and you could divide the bottom by 2 and make that 4/5. Okay, it's the same thing with radicals. If you have a radical or a square root on the bottom of the fraction, it is not reduced. It's not considered reduced. So when we rationalize the denominator, what we're going to do is get rid of that square root we have on the bottom of a fraction. Okay, so here are the steps to doing that. Start out with something, then we've got the square root of 5 over 3. Okay, now what we know from 6.3, which is what we talked about on the last lesson, we can break that down and we can write it like this. And it is, like I said, it's illegal to have a square root down here at the bottom. Well, I don't know if you remember this from what we just talked about, but I can get rid of this and change it to a whole number if I just multiply it by itself. Okay, but if I multiply the bottom by the square root of 3, I'm also going to have to multiply the top by the square root of 3, because if I don't, it's going to change the fraction. This number right now is just 1. Just like if I multiplied by 2 over 2, that's 1. If I multiply by 4 over 4, that's 1. If I multiply by the square root of 3 over the square root of 3, as long as the number is the same on the top and the bottom, what you're doing is multiplying by 1, which is perfectly legal, because when you multiply by 1, it doesn't change the number. Okay, so why do we want to multiply by the square root of 3 when we're doing this? Well, because look what happens when you do that. The square root of 3 times the square root of 3 turns into this. And what happens when you have a pair of something? Well, you get to pull it out of the radical, and it just becomes a 3 on the bottom. And now it's not illegal anymore because I don't have a square root down here, so I'm good to go. On the top, I would have 5 times 3. Those are both primes, so I know that I'm not going to be able to pull anything out of that, and it would stay the square root of 15 over 3. This is reduced. I don't have a radical on the bottom. So if I've got the square root of 1 over 2, I'm going to divide that into the square root of 1 over the square root of 2. And I'm only concerned with this bottom part. So you always want to multiply by whatever is down there that's underneath the radical. Okay, so that's going to turn to, on the bottom, the square root of 2 times 2. Since I have a pair of 2's, that's just 2, which is exactly what I wanted. I don't want a radical on the bottom. And on the top, I'm going to have 1 times 2, which is just the square root of 2 over 2. That's reduced. I don't have a radical on the bottom anymore. Okay. 5 over 7, we would do the square root of 5 over the square root of 7. I'm only concerned about the denominator, and I want to multiply by whatever is in that radical sign. So that's going to give me on the top 5 times 35. My brain worked ahead of time. 5 times 7, which is 35. And on the bottom, I would have the square root of 7 times 7. So that's going to end up being 7. On the top, we've got 35. And we're done with that because 35 is just 5 times 7. There's nothing I can pull out of that or reduce it. Okay. So, believe it or not, that's 3 of the 6 examples that we've got to look at on Chapter 6, Section 5. So, let me clear this out. We are going to turn it up just a little bit in a minute. Square root of 7 over the square root of 20. Well, if we're following what we were doing before, we would want to pay attention to the bottom and multiply by whatever that is. And we can still do that. So that's going to be 7 times 20 on the top. And on the bottom, we would have the square root of 20 times 20, which means I'm going to end up with 20 here. And I'm going to end up with 7 times 20 on the top, which is 140. Now, in all likelihood, that's not reduced because 140 is probably not made up of all prime numbers. So what we're going to have to do is we're going to have to do what we were doing before and look at the prime factors of 140. So we know that 2 will go into 140 70 times. 2 will still go into 70 35 times. 2 will not go into 35. 3 will not go into 35. 4 is not prime, so the next number we would try is 5, and it will 7 times. So we need to kind of look at this 140, that is 2 times 2 times 5 times 7 over 20. Okay, I can pull out this 2, and then underneath I would have left a 5 times 7 over 20. Well, so the 5 times 7 is just 35. Okay, the numbers that are in the front, though, the 2 and the 20, this is a fraction that I need to see if I can reduce. And 2 over 20, 2 can be divided by 2, and 20 can be divided by 2. So that really turns into 1 over 10 square root of 35. And just like when we have variables that don't have a number in front of them, we don't have to put the 1 there. This could just be written the square root of 35 over 10. Okay. Got the square root of 5 divided by 2 times the square root of 3. Okay. Remember that we don't really care about this number in the front. We only care about the radical sign on the bottom. So we want to continue to multiply by whatever's in that radical sign. So I'd still have 2 times the square root of 3 times 3. And on the top, I've got the square root of 5 times 3. Okay, that's going to get me the square root of 15. And then on the bottom, there's a pair of 3's here, which is exactly what we wanted that to be able to pull out with the 2. So the square root of 15 over 6. Now we would want to look at 15 to see that if we could divide it into, if it would reduce any further, but 15 is just 5 times 3 and that's prime. There's not going to be any pairs that I can pull out of that. Okay, this is the last example on 6.5. So 3 square root of 5 over 8 square root of 2. Okay, we only care about the radical and the denominator, and that's what we need to multiply on the top and the bottom. Okay, so on the top, I'm going to have 3 times 5, the square root of 5 times 2. And on the bottom, I'm going to have 8 times the square root of 2 times 2. So this is going to end up being 3 square root of 10. I can't reduce this square root of 10 because it's 5 times 2. There was no pairs I could pull out of that. On the bottom, though, this is going to be 8 times 2. So 3 square root of 10 over 16. So you want to focus on this number in the front, this 3 and 16. And you want to see, is it possible to reduce 3 over 16? I can't think of any numbers that go into those, so this would be my final answer. If I could, I would reduce that fraction if it would reduce, but it won't. So I am actually going to go ahead and cover 6.6, which is solving these equations, because it really is pretty easy. And I know that some of you we're looking forward to Thanksgiving break, and I have several of you that are on task to get things done. And if you want to get done with chapter 6, then there's only one more section. There's a chapter 6 test, and then there's one more test that covers a few more. I think we have 4 sections after this, and then it's time for finals. So I'm going to go ahead and cover this. That way I can review you for chapter 6 on the first class of next week, and then I can cover everything. My goal is to cover everything that we need to before Thanksgiving break. And after Thanksgiving break, we'll just review for final time. So this is 6.6, and 6.6 is solving equations with radical signs. And we're starting off, so 6.6, we're solving radical equations. Our first problem that we have is the square root of x is equal to 5. So we need x. We don't need the square root of x. And the way that you get rid of a square root is you do the opposite of whatever is happening. And so the opposite of the opposite of square rooting something, I guess, which is not the proper way to say that, I'm sure. The opposite of taking the square root of something is squaring it. So the way that you undo a square root is you square it. And if whatever you know by now in algebra that whatever you do to one side, you have to do to the other. So if I square this side, then I have to square this side. And I'm not going to write this every time, but I do want to show you. I mean, what we're doing when we square this is we're saying the square root of x times the square root of x, which is equal to the square root of x times x, which makes this have a pair that we can pull out, and it's just x. Okay, so that's how it undoes that. So 5 squared is 25. So x is 25. We're done with that problem. So the second problem is the square root of m plus 3 is equal to 9. So I'm trying to get m by itself. So I need to get rid of this plus 3. That's the first thing I would want to do. You don't want to take the square root first if there's something that's not attached that we need to get rid of. So I'm going to subtract 3 from both sides of my equal sign. 9 take away 3 is 6. And then I've got the square root of m. 3 minus 3 was 0, so that canceled out. I need to get rid of the square root. We talked about the way to get rid of a square root was to square it. And the square root of m squared is just m because of all this stuff we just talked about over here. And 6 times 6 gives you 36. So that's going to be the answer to that. Okay, I'm going to come down here just in case I've got somebody behind and write the next problem. The square root of 5x plus 2 is equal to 7. In order for me to get rid of this x right here, I need to get rid of this whole square root. So I'm going to have to take this square root. Okay, that's going to get me 5x plus 2 is equal to 49. Now I can get to this x by subtracting 2. So 5x is equal to 47. And then 49 divide by 5. These 5s are going to cancel out. So x is equal to 47 over 5. That's not going to reduce to anything nice. So we're going to leave it like that for that problem. Okay. The square root of 3x minus 4 is equal to negative 6. So the goal is to get this x right here by itself. So I'm going to get rid of the minus 4. I know I need to move it, so I'm going to add 4 to both sides of my equal sign. That's going to get me negative 6 and 4 is negative 2. These are going to cancel out. On this side, I've got the square root of 3x. Now I need to get rid of the square root. So we know to get rid of the square root, we're going to have to square both sides. Negative 2 times negative 2 is going to be 4. We're going to have 3x because this squared is going to undo that square root. Divide by 3 to get rid of the 3. And so we're going to get x is equal to 4/3. Okay. The square root of x minus 1 minus 3 is equal to 9. So we want to add 3. So we're trying to isolate this x, so we're moving things away from it. That's going to give you 12. And then we've got the square root of x minus 1. We want to square that. We square both sides, we'll get rid of the square root. And then we've got x minus 1 equals 144. We want to add 1 to move that. So x is 145. Okay. We have just a few problems left. What happens if it's not a squared that we're trying to get rid of, but it's a cubed? So remember to get rid of a square root. If this is what this said, right, we we would square both sides, okay, which is going to give us 4. But so how would you get rid of a cube root? Well, you could guess that you would cube both sides. Make sure you put things in parentheses when you're cubing them or squaring them so you can make sure you get the right answer. So y is equal to -2 times -2 times -2, which is going to be -8 on this one. Okay, we have 4 problems left. So the cube root of 3y plus 6 plus 2 is equal to 3. So we want to get y by itself, so we're going to subtract 2. 3 minus 2 is going to give me 1. And then I've got the cube root of 3y plus 6. I want to get rid of a cube. So that means that I need to cube both sides. Make sure you put it in parentheses because that's going to help you get the right answer, because you want to cube that whole number. And when you put it in parentheses, it makes sure that that happens. 1 times 1 times 1 is just 1 though. And then if I cube this, I'm going to get 3y plus 6. Subtract 6 from both sides. So we would get 3y is equal to -5. And then we would divide by 5. And so y would be -1. Because -5 divided by 5, I'm sorry, you need to divide by 3, not 5. Apologize for that. So we had, right here, we have 3y is equal to -5. Divide by 3, I apologize. And so we're going to, 3's would cancel out, and y is equal to -5/3, and that's not going to reduce. So we would leave our answer like that. Then we're getting extra crazy here, and we're saying, oh, we got to get rid of a 4th root. Well, to get rid of a 4th root, you are going to not raise it to the 2nd power and not raise it to the 3rd power, but you're going to raise it to the 4th power. So we want to do that to both sides of our equal sign. We get x plus 3 equals 3 times 3 times 3, which I know is 27, times another 3, which is going to be 81. 3 to the 4th is 81. We would subtract 3. So x is equal to 78. Okay. So there are 2 problems left in 6.6. They're a little bit different, but same concept. To me, they're not as difficult. So I've got, the first problem is 4y minus 2 equals, or the square root of 4y minus 2 is equal to the square root of 3y plus 9. I can't get to those y's unless I get rid of the square root. And you guys know, I hope by now, to get rid of a square root, we're going to have to square both sides, which is nice because I need to get rid of both of these square roots. So that's going to leave me with 4y minus 2 equals 3y plus 9. Another thing you know is that you can't have square roots on both sides, or you can't have letters on both sides of your equal sign. So you've got to move all your variables to one side. You could either subtract 4y or subtract 3y. I'm going to go ahead and go with the 3y. So 4y take away 3y is 1y minus 2. And then I'm just going to end up having 9 on this side. Add 2. So 1y is equal to 11, which is going to be our answer. Last problem is very similar. We've got the square root of 2y minus 7 is equal to the square root of 8 minus y. So we want to square both sides, because that's going to get rid of the square roots. I'm going to get 2y minus 7 equals 8 minus y. We can't have variables on both sides of our equal sign. I'm going to choose to add a y to both sides. I could have subtracted 2y. Either one would work. And there's no number here, so I know this is a 1. So 2y plus 1y is 3y minus 7 equals 8. Still keeping my equal sign lined up. I want to add 7 to both sides of my equal sign. That's going to get me 15. And bring down the 3y, divide by 3. So y is equal to 5. Don't forget, you can always go back and plug these in. This is algebra. So if I go back and plug this in, 2 times 5 is 10. 10 minus 7 is 3. And on this side, 8 minus y, which we said is 5, is 3. So we would get the square root of 3 is equal to square root of 3, which is correct. So that is the end of chapter 6. You might have to go back and look at this. I know you might not handle 3 sections at once when you're doing your homework, but you can go back and look at this. Fast forward the video. I'm fixing to post this